Just looking at homework problems here. The first one is question 4A. Find the exact value of this. So girls, the first thing you want to do is let alpha equal inverse sine of negative half, and let beta equal inverse cos of negative a half. That means that sine alpha is negative a half and cos beta is also negative a half. Sine of what is a half, by the way? Sine of what? Sine of 30, which is pi on 6. But girls, sine is negative in which quadrants? 3 and 4, but girls, we're not allowed to go near quadrant 3 because the inverse sine function is only has a range. Do you understand what I mean by that? If I draw the inverse sine function, that's that one, it has a range of, so this is the inverse sine function. I just remember it as, it's like the y equals x cubed curve. That's how I sort of remember, and the other one's backwards. So we start this way, we go that way for the inverse cos, and the other one's that way, the inverse tan curve. So you're going to look, I don't know how, look, if you remember what the normal sine curve looks like, you can do that as well. If you don't like drawing the inverse sine curve, which is here, see, the inverse sine curve can only have y values of negative pi and 2 to pi and 2. Or if you do draw the original sine curve, you're not allowed to use all of it. The bit of the original sine curve that we use to come up with the inverse function is this bit, the monotonic increasing bit of the original sine curve. So the original sine curve, when we, at the very beginning of the video that I did yesterday, I drew the sine function and I said we can only use this bit for the inverse function. Now this is y equals sine x. This is the bit of the sine curve here that I use for the inverse function here. So notice the domain is from negative pi and 2 to pi and 2, and the range is from 1 to negative 1. The range becomes my new domain, and the domain here becomes my new range for my inverse curve. So that's why, I'm not finished here by the way, that I'm only allowed to go, sine of what is negative a half? It's quadrant 4, so it's minus pi on 6, minus negative pi on 6, because it's got to be the quadrant 4 angle. Okay, because you're going quadrant 4, see quadrant 1 is 0 to pi and 2, quadrant 2 is pi and 2 to 90, to pi, sorry, pi and 2 to pi, which is 90 to 180. 0, pi and 2, pi. Minus pi and 2 if we're coming this way, minus pi all the way. But the inverse sine curve is only from minus pi on 2 to pi on 2, quadrants 1 and 4. The inverse cos curve is different. So, well, yeah, no. The inverse cos curve looks like this. That's the inverse cosine curve. From pi to 0, 1 to negative 1. So it's got a range from 0 to pi. So cos of what is a half, girls? And which quadrants are we in? Cos of what is a half, girls? Cos of 60, which is pi and 3. Which quadrants is cos negative in? 2 and 3. I'm allowed quadrant 2 because that takes me up to pi. So I'm definitely talking quadrant 2, acute angle pi and 3. So therefore beta is how do I get quadrant 2, girls? Isn't that angle 120?
Yes.
Got it?
2 pi.
2 pi and, because when
Did you say it was angle 330?
because you're only allowed to go from negative 90 to positive 90. So if you go 330, that's way beyond 90. So you've got to go negative 30. Negative 30, which is negative pi and 6. Here, I'm allowed to go from 0 to 180. So, I'll go, that is 60, I've got 120 degrees. 120 is 2 lots of 60, which is 2 pi on 3.
Oh, isn't it? Like pi minus pi on 3.
Oh, it is pi minus pi on 3, which is 2 pi on 3. Yeah, we're going to do that today, actually. So we're going to do pi minus pi on 3 today. We're going to do all that today. Yeah, it's the same. It's the same. So, yeah, because quadrant 2 is 180 minus, or pi minus. So we're going to do that. We're going to formalise it today. But this is, so do you sort of get what I'm doing here now? And why it's got to be, it can't be quadrant 3. Because of this, because when I draw the inverse cosine curve, the y values lie between 0 and pi. So your answer to this has to lie, see the inverse cosine curve, and I can tell from here, it started as an inverse cosine curve. I know I've written it now as a normal one, but I must stick to the range of this function here in my answer. I can't just ignore that I've written that first line. So yeah, I know that this could be positive 120 minus 120, or positive 2 pi on 3, negative 2 pi on 3, but the positive 2 pi on 3 is the only one that fits in the range of the inverse cosine function. Got the idea? So therefore this is 2 pi on 3. So therefore my answer is negative a half plus 2 pi on 3. We okay with that?
No, it's negative pi on.
Thank you. Negative pi on 6 plus 2 pi on 6 is negative pi on 6 plus 4 pi on 6, common denominator, 3 pi on 6, which is pi on 2. Got it? All right. Which other problems with the homework?
5B.
Yep. So we need to spend a few lessons on this, girls. Maybe got to get this right. Okay? 5B. The question is inverse cos of negative pi on 4. Now you're going to see something that happens in a minute. They can just cancel. I know I made you do all these, but you've got to be careful. You've really got to be careful because with D, you've got to be in the proper range depending on which one's written first. So C minus pi on 4 doesn't fit in the range of the cosine curve. You've got to go from 0 to pi. Let's just have a look. So inverse, all right. So girls, when I just look at this, no, it will be fine, because when I just look at this bit, it's the cos of negative pi on 4. Don't worry about this inverse cos yet. What's the cos of negative pi on 4 mean? Cos of what? Negative angle goes clockwise. It's this. Which quadrant are you in? 4. So what does cos of negative pi on 4 equal? Cos of 45, what is it? 1 on root 2. Is it going to be positive or negative? So that's inverse cos of 1 on root 2. And? No, because all stations to central, cos is positive in quadrant 4. So this is a quadrant 4 angle because it's a negative angle. Got to go backwards. All right, so inverse cos of 1 on root 2, so you can let this equal alpha now. So that means cos of alpha is 1 on root 2, provided this now fits in the domain from 0 to pi. We're fine. I'm not in the domain. That you answer the range. This is like y equals, all right? As long as, so cos of what's 1 on root 2? The answer has to be positive pi on 4, not negative pi on 4. So none of this let's just cancel out business. We can't do it. Sometimes works, sometimes doesn't. Probably work with cos, but it won't work with, no, it may not work with cos. It'll work with sine. Sometimes works with cos, depending on if you're doing the inverse one first or second. So don't go learning blanket rules. You just need to work them out, okay? So that means that alpha is going to be pi on 4. Because once I get to here, I must respect the range of the inverse cosine function. I must be between 0 and pi on 4. So no, let's just cancel them out because you will get the wrong answer. You're not allowed to say the answer is negative pi on 4. But while we're here, let's look at 5D, which was inverse cos of cos 5 pi on 4. I know people haven't asked for this, but we're going to see why that one's going to be different to this other one. So cos of 5 pi and 4, we're not doing any inverse causes yet. Just treat it like normal. 5 pi and 4, where's that? Is it more than pi? Yeah, it's over here. It's more than pi. How much more? That's pi plus pi on 4. That's 1 1/4 pi. So there it is. Quadrant 3 is cos positive or negative. So that's the same as the inverse cos of negative something. 1 on root 2. Now, inverse cos of negative 1 on root 2. Now we have to stick with, I'm going to let this equal y or alpha, it doesn't matter. So cos of y is negative 1 on root 2. Cos is negative in which quadrants? 2 and 3. But this is an inverse cosine function from this point onwards. The inverse cosine function looks like this, and your answer has to lie between 0 and pi. So it's got to be the second quadrant one. So you're not allowed to do this down here. That's out. It has to be the second quadrant. We know this is 45 degrees. Cos is negative. So what's that angle? It's, yeah, if it's pi minus pi and 4. Do you get it? It's pi minus pi and 4, which is 3 pi and 4. So that's the answer to the whole question. So if I'm going to let y equal that. So first you work, so these are tricky, girls. They're not, you've got to consider each one separately. You don't worry about inverse cosine while you're here. This is just normal angles. Once you start inverse cosine of this, you've got to now consider where your answers can lie between. Really important that you can draw these inverse cosine functions. All right, so I just do it as x cubed going through 0. The cos one is the negative x cubed type, but I lift it up. And then the other one, the tan one, I think goes like this. From minus pi and 2 to pi and 2. So you just got to learn those. Come up with some little thing that's going to make you remember. All right, which other questions do we have? 7 what? 7b. Are you okay? 7b. What is the question? We've got the cos of tan to the minus 1/2. So girls, one of these was in your trial that I crossed out because we hadn't done it yet. And it was one like this. Okay?
Oh, I struggled.
No, I crossed it out. You weren't meant to do that question.
Oh.
Okay, so, but the way you would do it is what we're doing here. All right, so girls, let alpha equal tan to the shift tan of 1/2. Let beta equal shift tan of 1/4. Ladies, please. Girls, let the first one be alpha. Let the second one be beta. Tan of alpha is, what is it? And sine of beta is 1/4. Girls, I think so. I'm not sure which ones I need. Let's just, yeah, we are going to need cos and sine, I believe. Yes, because it's going to be cos of alpha plus beta. See, if we let alpha be tan, shift tan to the minus 1/2, and beta is the inverse sine of 1/4, this question's becoming cos of alpha plus beta. Do you get that? Which is cos alpha cos beta minus sine alpha sine beta. So I'm going to need sine alpha cos alpha sine beta. So alpha here, tan is 1/2. This one's the square root of what? Root 5. This is beta. Sine is 1/4. Square root of 4 squared minus 1 squared, 15. Because when I come to work out cos alpha plus beta, what does cos alpha plus cos beta equal? Double angle result. Cos alpha, cos beta, minus sine alpha, sine beta. That means I need cos alpha, which I don't have. I've only got tan alpha. So girls, once you know tan alpha is 1/2, so katoa, sine cos tan, a right angle triangle trigonometry, SOHCAHTOA. It's right angle trig. If you know any one ratio, you automatically know the other two by drawing the right angle triangle. So here, what's cos alpha?
205.
What's cos beta tells me to go to the other triangle. Do you see that? 2 on root 5. Cos beta is telling me I need the beta triangle, which is root 15 on 4. Do we get it? Minus sine alpha, which triangle? The alpha triangle. What have we got? 1 on root 5. Sine beta is already given, but it is 1 on 4. Can you see? So girls, what's the common denominator? Is it common?
4 root 5.
Thank you. Common denominator, 4 root 5, 4 root 5, it's 4 root 5. So what is my answer? 2 root 15 minus 1. That'll do. Oh, they might want it rationalised. So what do you multiply this by to rationalise it? Times? You don't need to do it by 4 root 5 on 4 root 5 because the 4's cancel. Times root 5 over root 5, which is, expand. 2 root what? What's 15 times 5? I think it's 75. Minus that times that, that times that. Minus what? Over, what's 4 root 5 times root 5? Now you can call out your little 20.
2 root 15 times root 5.
Yes, 2 root 15 is 2 root 75. Do you get that? Because 15 times 5 is 75. So what's my denominator? 20. Now, what's 2 root 75? What goes into 75? 25 and 3. So it's 2 times 5 root 3, which is? We okay with that? Minus root 5 over 20. Forget it, you can't simplify it. Why can't you simplify?
That's the right answer.
Why can't you simplify this? Don't you even think about cancelling the 10 and the 20. Why?
Because the other one.
There's nothing to cancel here because that 20 is common to both numerators.
You said that was like 2 root 5 you could.
Yes, that's right, you could, but you can't. Yeah, because that's really 10 root 3 over 20 minus root 5 over 20. If you start playing with this denominator, poor little root 5 lost its denominator. All right? So, no, don't cancel until there's something in common with both terms that can cancel. All right, what else? Remember you watched my little thing on cos 2 theta and I showed you 3 ways to do it? There are 3 rules for cos 2 theta. Double angle cos, what are they? Cos squared minus sine squared. 1 minus 2 sine squared. And 2 cos squared minus 1. You've already got the sine. Why go and do a triangle? Why go and do all this extra work when you don't need to? So, if alpha is sine to the minus 1 of 3/5, that means that sine of alpha is 3/5. So, cos of 2 alpha, isn't that equal to, actually I'll go down here. Cos of 2 alpha, you've got one of 3 formulas to choose from. Not sine of 2 alpha, you've only got one. Tan of 2 alpha, you've only got one. But cos of 2 alpha or 2 theta, you have, I should have let this equal theta, which is fine. Okay, so cos of 2 theta, you've got 3. Make sure you choose the right one. 1 minus 2 sine squared theta. How do you remember it? This is the cos one, so the sine one's the negative. Whereas the cos one's 2 cos squared theta minus 1. They go together, you can think, sort of. So it's 1 minus 2 times 3/5 squared. Get the idea? 1 minus 2 times what over what? 9 over 25. 1 minus 18 over 25, which is 7 over 25. So cos 2 theta is 7 over 25. It then says part 2, hence show that the inverse cos of 7 over 25 is equal to 2 times the inverse sine of 3/5. Okay. All right. There's a few ways we can do it. I don't know, I'm just trying this. Cos of 2 theta is 7 over 25. Cos of 2 theta is also equal to 2 cos squared theta minus 1. So 7 over 25 equals 2 cos squared theta minus 1. I'm trying to come up with cos to the minus 1 of 7 over 25. You know that that's just really cos theta is 7 over 25. Because if you let theta equal that, what are we going to do? What do you think you'll do? Add 1? So 7 over 25 plus 1 equals 2 cos squared theta. Yeah, this is going to work. Can you write that as one denominator? What am I going to do with this 2? And then what happens? When you divide by 2, do you see what I'm doing, girls? Yeah. 7 over 25 equals that. 7 over 25 plus 1 is 2 cos squared theta. Divide by 2 and what do you get? 16 over 25, this is looking good, is cos squared theta. Why is it looking good? Because they're both able to be square rooted. Cos of theta is the square root of 16 over 25. It is the plus or minus, by the way. And which one are you going to use? Why? This is not... I got 4.
Yeah, 4 and 5, and then you did the triangle. 4 and 5. Why'd you get 25? No, 4 and 5 means you have to root the 25.
I know. What's that?
This wants to get 7 and 25.
Oh, yeah, got it. Oh. The long way about this ending up nowhere, the answer's actually there. If cos of 2 theta is 7 over 25, all right, so this is what we've got. Cos of 2 theta is 7 over 25. Doesn't that mean that 2 theta, so we can see we've got is inverse cos of 7 on 25. And we also saw so we had this, cos 2 theta is 7 over 25. So 2 theta is cos to the minus 1 of 7 over 25. Over here, we know that theta is sine to the minus 1 of 3/5. So theta is sine to the minus 1 of 3/5. So therefore 2 theta is 2 times sine to the minus 1 of 3/5. And there it's done. Jeez. Therefore, cos to the minus 1 of 7 over 25 equals 2 sine to the minus 1 of 3/5. Why? Because they're both equal to 2 theta. Jeez, I'm really sorry. That was so basic. I don't know where I was going. I don't know. So have a good look at the question before you start moving about around in circles, getting nowhere. That was really easy. Sorry. All right, I'll just, sorry about that. Is that all you did? Yeah.